Good evening, ladies and gentlemen. Welcome back to the Tarantula Wizard Radio Show. Today we have another exciting show for you, where we will be interviewing someone who won the 1923 Nobel Prize in Physics. So to start with, let's just ask them to introduce themselves and tell us a little bit about the project that made such an impact on the world of physics. Yeah, well, let me start with saying that it's an absolute pleasure to be on the show, and yeah, so my name is Dr. Robert Andrews Milliken. Definitely my most notable achievement, and something that most people are asking about would be the oil drop experiment. Well, I, along with Harvey Fletcher, were actually able to determine the charge of an electron. And I would say this definitely contributed the most to uh, the 1923 Nobel Prize in Physics that I was awarded. Yeah, and also, later on, I'm sure we're going to get into more specifics of the interview, but one word that people like to use to describe this experiment, and in a way, the project itself is beautiful because it's really relatively simple, but yet it was able to achieve pretty good accuracy for the time in measuring what would become a constant in the world of physics. Well, Dr. Milliken, that is certainly an interesting description of the project, and I think that we should just go right into why people describe it that way. So, for my next question, what exactly were you and anyone that you worked with trying to find or do? Yeah, so that is a great question. And I think to really give it justice, I'm going to start with a little background information before I really delve into what we were trying to do and achieve. So, at this particular time, I was working as a relatively successful educator and textbook writer, um, and I knew deep down that I hadn't really made any lasting contribution to the scientific community, and I was always on the lookout for such an opportunity. And prior to this, about a decade or so, J.J. Thomson discovered the electron back in 1897, and he and his team were able to determine the charge to mass ratio, and naturally they thought that the next step was to determine the charge itself. So I was aware of efforts to do this, and so that kind of got me thinking about ways to improve upon their procedures. These procedures produced fairly crude results. So the start of the project was really looking at what people had done before us and figuring out ways to improve upon that. And I suggested to one of my graduate students at the time, Harvey Fletcher, who I mentioned before, to find a substitute for using water because water would evaporate, which would affect the results and give, as I said before, crude results. So he suggested using oil, and that's exactly what we did. And just to briefly go over how the experiment worked, so in short, oil droplets are injected into an air-filled chamber where they pick up charge from ionized air. The drops then fall or rise under the combined influence of gravity, viscosity of the air, and an electric field, which can be adjusted as needed. Then these drops could be observed through a specially designed telescope and timed to determine how fast they rise or fall. The charge could then be calculated. Thank you for that explanation, Dr. Milliken. For the next question, where exactly did the project occur? Yeah, so as I mentioned previously, I was working as an educator at the time. So this experiment and most of the experiments that I did took place on the university campus itself, specifically at the Ryerson Physical Laboratory. The oil drop experiment, though, took place in 1909, like the first few tests, and then, years later, we would continue to improve upon it to get better data. For our next question, what other significant events that you know of were happening around the world at that time? Yeah, that's a cool question. So specifically in 1910, I do recall the really interesting event in the world of astronomy, uh, known as the Great January Comet, which was a comet that flew past Earth that was so bright and brilliant that you could see it even in the daytime. And so it earned the nickname the Daylight Comet. A few years later, even more well known was the sinking of the RMS Titanic in April of 1912, which would go on to influence safety regulations of almost every type of ship. Who else was involved in the project? So it was mainly myself and some of my graduate students, specifically Harvey Fletcher, who, as I mentioned before, came up with the idea of using oil instead of water. I realize your previous question might have answered some of what would be in this next question, but just for the clarification of our listeners, how would you describe your role in the project? If I had to describe my role, I guess I would describe it as project lead. But as you mentioned earlier, that seems perhaps unnecessary given that it was basically just me and Fletcher. But I was certainly the one making the decisions and leading the project. Discovering the value for a physical constant is pretty huge. So, what impact do you think your project had on the physics community at that time? That's a great question, and kind of a difficult one to answer. Because, as you mentioned, it was the discovery for the value of a physical constant. So, it's been used in countless experiments and calculations in many different fields. But I think specifically, though, it's been very important for fields of physics that deal with very small molecules. For example, quantum physics. Well, Dr. Millikan, we only have one more question, but it could be a pretty important one. How do you respond to claims of fraud in regards to the oil drop experiment that you performed? In short, we were very transparent with the experiment. We provided all of our notes, all of our journals that we took, and we gave them to the proper authorities to review them and determine if the experiment was legitimate. And the consensus was that it was. There are a few people who still find it suspicious that we threw out some data points uh, that would lower the accuracy of our measurement, but we simply did that because we knew that there was error in those specific measurements. Like something wasn't right, and we just wanted to redo those and make sure that we got the best result that we could. Thank you, Dr. Milliken, for coming on the show and telling us about the oil drop experiment that led to the discovery for the value of the charge of an electron. So we wish you well, and we hope to have you back on in the future. Well, thank you. It was truly a pleasure, and I hope to be back on as well.